So once you have this, right, you now can find your omega CIC. Okay, so we know that VC is equal to omega CIC, and then we are going to take the length C to IC length. Okay. So VC is equal to 12, or omega CIC will be equal to 12 divided by C to IC is equal to 5.464. And this will be equal to 12 divided by 5.464 is 2.196 radians per second. Okay, and this is also equal to your omega B to IC, right? So now from here we can find our VB, which is equal to omega BIC multiplied by B to IC. Okay, so this will be equal to 2.196 multiplied by B to IC is 2.828. So 2.196 times 2.828 is equal to 6.21 inches per second. Okay. So after we know this, what this means is VB is equal to what? 6.21. So therefore, okay, you're going to bring it back okay, we're going to bring it back to the non-IC domain. Okay, so now imagine we don't have IC now, but we know that this is equal to what? 6.21 inches per second. So when that's the case, we know that omega AB will be equal to what? 6.21 divided by what? 5. Okay, so 6.21 divided by 5, 1.242 radians per second. Interesting, isn't it? Right? So what we have just done, okay, if you were to look at the entire process, right, you have to construct, or you have to get your angles from the diagram. Then you're going to analyze, I'll call this the IC domain, okay? Instantaneous domain. You isolate, you get rid of the figure, you pull it out, put into a diagram like this. Determine all your distance relative to the perpendicular distance relative to the instantaneous center, okay? And then you have to know the rule that what you have just done is this is so-called the rigid body in the instantaneous center domain. Then you know that omega BIC is equal to omega CIC. Then you determine your velocity, and then you bring everything back in. Such analysis is good where people don't understand vectors. You get where I'm coming from? If you don't comprehend vectors, this is the way. But the limitation is what? You have to know the what? Orientation of the velocity. I repeat again, you have to know the orientation of the velocity. Okay, what I'm going to do next is I'm going to do a problem using the combined effect. Okay, so you guys, I want you all to, I know it's a very short time for you to like boost your confidence, but I'm going to do it. Let's try dealing with this problem using the combined instantaneous method and the relative velocity technique. Okay, so let's see. Okay, because this is quite a good eye opener. Okay, so you all can remember this problem, yes or no? Right? Okay. Okay. So let's look at this problem. Okay, so we are going to use, okay, or what this problem could help us is, example, to show when it is possible to use the IC method. Okay, so you guys have seen this problem. Okay, this is the first problem we talk about. Okay, so now we are going to use the instantaneous method. Okay, like before, we know that we have rigid body. Right, ABD. Okay, so we understand that this will be going downwards. Okay. Right, 4 meters per second. And we know point B is going towards the right. Okay, we know this is VB, right? And then we are aware that this is joined by a rigid body, or by between A to B. Okay. So at this moment, with these 3 points, I'm going to take it out. And now, this we know is our point B. And this we know is our point A. Right? So we know that this is going down at 4 meters per second. So the next thing we're going to do, so we are going to analyze AB in the instantaneous center domain. Okay. So remember what I told you? We construct what? 90 degrees line. This is 90 degrees from here to here. This is 90 degrees from here to here. And where it intersect, this is your instantaneous center. Remember what they say, the instantaneous center can be outside the rigid body? This is one good example, right? So what we are doing now is, this is now our rigid body, points in a rigid body. Okay? So when that's the case, we know that omega I, right? Omega A IC is equal to omega B IC. Okay. Yeah, I've started recording and I've shared screen. Okay. So the next thing we have to do, again, the same thing, right? We have to determine what is our BIC and what is our AIC. Okay. And we know that this is equal to 300 plus 250 is equal to 0.55 meter. Okay. So we are going to use, we don't need to use the angle down here. We know that this is 3/5. And this is equal to BIC over by what? 0.55. Okay. So your BIC is equal to 3/5 times by 0.55 is equal to 0.33 BIC. Let me, yeah, 0.33. And this is in meters. And then we know that we can, okay, so for you got your AIC and you have 0.55. So now your A to IC will be equal to 4/5, 0.44. Okay. And then from here, right, we can now determine our, so we can determine what is our what? Omega A IC. And we also can determine, knowing that, we can also find out what is our omega B IC. Okay. So from here, we know what, from here, we will know our, we know that the 4, so we know that VA will be equal to what? Will be equal to omega A IC multiplied by a distance AIC. So now your VA is 4, omega A to IC. So AIC is 0.44. So therefore, omega A to AIC is equal to 4 divided by 4.44 is 9.091 radians per second. So for this case, we can find our BB. So VB is equal to omega B to IC multiplied by B to IC. Right? So this is equal to 9.091 multiply B